So this is quite an unusual differentiation exam question from one of the June 2018 papers. So if you want to have a go at the question, pause the video and I'll go for the answer now. Okay, so for this question, we're given this figure here, and we're told this is a sketch of the curve with equation x squared minus 2xy plus 3y squared is equal to 50. And for part A, we need to show that dy over dx is equal to y minus x over 3y minus x for 4 marks. So we need to find dy over dx, so we need to differentiate this equation here. Now, as on this side of the equation, we have both x and y terms, we're going to differentiate this implicitly. So the way that we're going to do this is if we differentiate all these terms here, so if we start with the x squared, if you differentiate x squared, we're differentiating in terms of x, this is just going to be 2x. If we differentiate minus 2xy, so it's going to be minus 2, and then this is going to be multiplied by xy differentiated. Now the way that we differentiate xy is we use the product rule. Now the way that I taught the product rule is just this term differentiated multiplied by this term plus this term differentiated multiplied by this term. So if we use the product rule for xy, it's going to be this term differentiated, which is x differentiated, which is 1, and this is multiplied by this term, which is y, and then this is plus this term differentiated, so y differentiated, and we differentiate y implicitly to dy over dx, and then this is multiplied by this term, which is x, so it's like this here, and therefore here we have this minus 2 times 1 times y, which is minus 2y, and then we have minus 2 times dy over dx times x, which is going to be minus 2x dy over dx. Okay, and then if we differentiate this 3y squared, so it's going to be 3 multiplied by, and then if we differentiate y squared, we talked about in the implicit differentiation video, we differentiate this implicitly using the chain rule, and it's equal to 2y dy over dx, like this here, and then 2 times 3 is 6. This is going to be 6y dy over dx, and then on this side here, when you differentiate 50, it's just a constant, so it's just going to be 0. So therefore, if we differentiate this equation here, it's going to be these terms added together, so it's going to be 2x minus 2y minus 2x dy over dx plus 6y dy over dx, and all of this is equal to, as when you differentiate 50, it's equal to 0. This is going to be equal to 0, like this here. Now we need to show that dy over dx is equal to this here, so we need to make dy over dx the subject. So we have these dy over dx terms here. Let's keep them on this side of the equation and move this 2x minus 2y onto this side of the equation. So on this side of the equation, we're still going to have the minus 2x dy over dx plus 6y dy over dx, and then this is going to be equal to, and if we move this 2x minus 2y onto this side, it's now going to be 2y minus 2x, like this here. If we factorize out dy over dx from this side here, it's going to be dy over dx, then it's going to be minus 2x plus 6y, and this is equal to 2y minus 2x, and then if you divide both sides by this minus 2x plus 6y, you get dy over dx is equal to 2y minus 2x over minus 2x plus 6y, like this here. Now we need to show that this can be written in this format here. This is the equation that we have here, except everything in here is multiplied by 2 in the fraction. So if we just divide everything in the fraction by 2, it's going to be dy over dx is equal to y minus x, like this here. I'm going to write this the other way around, so I'm going to write this 6y first, and if you divide it by 2, it's going to be 3y, and then minus x, like this here, and this here is dy over dx as they want here. Okay, so the question goes on and it says the curve is used to model the shape of a cycle track with both x and y measured in kilometers. So this is kind of the cycle track here. It kind of has this oval shape. And the points P and Q represent points that are furthest west and furthest east of the origin O, as shown in figure 4. So we have the x-axis here where it goes from east to west. This is the point Q, which is the most east point, and this is the point P, which is the most west point. And using part A, for part B, we need to find the exact coordinates of the point P for 5 marks. So we're given a clue that we need to use part A, which we found dy over dx. So for these points here, P and Q, let's consider the value of dy over dx, which is going to be the gradient. Now, just for reference, let's consider this point here and this point here. So if we draw a tangent to these points like this here, we can see that this is a horizontal line, so that means the gradient is equal to 0. So that means dy over dx, which is the gradient, is equal to 0. If we consider the points P and Q, so we've kind of already got these tangents drawn on like this here. This is essentially the opposite, where the tangent is a vertical line, so the gradient is vertical. When you have something like this here, so dy over dx, which is the gradient, you can say it's equal to infinity if you want, but the better way to say it is that it's approaching infinity, the gradient at this point here, P and Q. So dy over dx is approaching infinity for P and Q. As in part A, we found dy over dx is equal to this here, we can say that y minus x over 3y minus x is approaching infinity like this here. A fraction is approaching infinity when you're dividing by 0. Here the denominator is 3y minus x, so this is where 3y minus x, the denominator, is equal to 0, because this is where we're dividing by 0. And we have this equation here. Now really quick, there is another way that you can look at this question. It's probably the way that I would prefer, but maybe at A level I think it's probably the more complicated way. If you instead consider dx over dy, so this is the flipped version of dy over dx, it essentially works the complete opposite way. So here, where dy over dx is equal to 0, dx over dy would be approaching infinity like this here. So down here, where dy over dx is approaching infinity, dx over dy is going to be equal to 0. And what we can do with this, if you remember that dx over dy is equal to 1 divided by dy over dx, so therefore dx over dy is equal to 1 divided by this here, this y minus x over 3y minus x. Remember, when you do 1 divided by a fraction, it flips, so dx over dy is equal to 3y minus x over y minus x like this here, and we said that this is where dx over dy is equal to 0. So this 3y minus x over y minus x is equal to 0, and this would give us the same equation, that 3y minus x is equal to 0. So this is just a different way of thinking about it, but it gives the same equation. This 3y minus x is equal to 0. So therefore, if we move this minus x to the other side, we get that 3y is equal to x, and we can use this equation here, because what we can do is we can sub this into the original equation of the curve here. So this equation is x squared minus 2xy plus 3y squared is equal to 50. And what we can do with this is, so we have x is equal to 3y, so we can sub out all of the x values here for 3y. So x squared here, instead of x squared, it's going to be 3y squared, and then minus 2xy, so it's going to be minus 2y, and then instead of x, it's going to be 3y, and then plus 3y squared is equal to 50. We can simplify this, so 3y squared is equal to 9y squared, and then minus 2y multiplied by 3y is equal to minus 6y squared, and then plus 3y squared is equal to 50. 9y squared minus 6y squared plus 3y squared is equal to 6y squared, and this is equal to 50. Divide both sides by 6, we get that y squared is equal to 25 over 3. So if you square root both sides, you get y is equal to, if you put it into your calculator, it's equal to 5 root 3 over 3. But of course, remember, when you're square rooting, it can be the plus or minus of this here. So which way round is it for P? So is it the plus or minus? Well, we can see for this point P and for this point Q, so for Q, this is above the x-axis, so therefore y is going to be a positive number, it's going to be bigger than 0. P is below the x-axis, so the y value, y is going to be less than 0, like this here. So therefore, for the point P, this is going to be the negative value where y is equal to minus 5 root 3 over 3. So this is the y coordinate. So now we need to find the x coordinate, and we know that 3y is equal to x. So therefore x is going to be equal to 3y, so it's going to be 3 times this minus 5 root 3 over 3, which is equal to, so this 3 will cancel out this 3 denominator to leave us with minus 5 root 3. So we have the x and the y coordinate, so therefore the point P is equal to minus 5 root 3 minus 5 root 3 over 3. And this is this point here, P. Okay, and then for part C, we need to explain briefly how to find the coordinates of the point that is furthest north of the origin O, and it stresses that you do not need to carry out this calculation because it's only worth 1 mark. So the point that is furthest north is this point here, and we've already talked about this point. This is where dy over dx is equal to 0. So therefore what we're going to do, dy over dx is equal to 0. We know dy over dx is equal to y minus x over 3y minus x, and this is equal to 0. So therefore this is going to be where y minus x is equal to 0, so this is therefore going to be where y is equal to x. So we're going to do the exact same thing as before, so we're going to sub this y is equal to x into the equation of the curve, which is x squared minus 2xy plus 3y squared is equal to 50, and find x and y. Now there's one other thing you need to do here to get the mark, and it's something that we've considered in part B. There are actually 2 points where dy over dx is equal to 0. There's one here, but there's also down here as well. This is also where dy over dx is equal to 0. Like we did before, up here, this is where y and x, they are both positive, they are both bigger than 0 because they're in this quadrant here, where down here this is where y and x are less than 0. So therefore we need to pick these solutions in order to find the point that is furthest north instead of the point that is furthest south. So just say something like x and y are both positive, and this will give you the 1 mark.